Hello friends, welcome once again to ASONOR for Online Maths. This lesson is proudly powered by your lesson app. So we are going to introduce the partial derivatives in this lesson. So before we go into the applications of differentiation, so I decided to touch the partial derivatives. Now I want you to understand the concept of these partial derivatives before we go straight into solving this problem here. Now look at this shape. Of course, we all know that this is a cone. A cone is a pyramid, okay? A circular base pyramid. You understand that if you want to get the volume of this cone, that the volume of a cone is 1 over 3 pi r squared h. This is the formula for getting the volume of a cone. The volume of a cone is dependent on the height of the cone as well as the radius of this cone. That is one thing you need to know here, because an increase in the height will cause an increase in the volume. As you are increasing the height, you are increasing the volume. If you also increase the radius of this cone by increasing the size of the radius, you are also increasing the volume. So to tell you that the volume is related to this height and the radius directly. Any change in this radius and height will cause a change in this volume. So you see that these are partial sums of this. Okay, now supposing, let me show you what I'm trying to say here. If I want to increase the height, this is now the height, I want to increase it. So this is what will happen. So we have something like this. The height has been increased. So by increasing this height, automatically you have increased the volume. Usually, the differentiation we've been doing all this while, you will notice that x and y are written independently. All right. So if I want to get the partial derivative here, so a function of u depends on x and y. So supposing I want to get the partial derivative of this function here, right? So maybe ux, you substitute x, or you can write it as delta x or delta u all over delta x. This is for partial derivative. The ones we've been doing all this while is dy over dx. That is a total derivative. That is what we are doing. But this is partial, so this is what you have to do. So in differentiating this with respect to x, you have to treat your y as a constant. All right? And when you differentiate with respect to y, you also treat x as a constant. Now, delta u over delta x will be, this is the power of 3 for x. If I differentiate it, the power of 3 comes to the back. X 3 minus 1. Y is a constant, so you still leave it. Minus, if I differentiate 2x, the power is 1. So if you differentiate 2x, you get just 2. You leave y alone. And this y, I'm not going to write it because that will be 0. You are treating y as a constant. So if you differentiate y power 3, it will be 0 because it is a constant. So finally, delta u all over delta x becomes 3x squared y minus 2y. Supposing I want to find uy, which is delta u over delta y. This time around, I will treat x as a constant and differentiate y. So here, if I differentiate y, y has gone because if you differentiate a value without a coefficient beside it, the coefficient is 1, you just get 1. So 1 times x cubed is the same thing as x cubed because x is a constant now, minus, here, if I differentiate y, it is still 1. I'll be left with minus 2x, which is a constant, plus, if I differentiate y cubed, the power of 3 comes to the back, y 3 minus 1.